about concave mirrors and the images they form. We finished off the third one by taking a look at the image formed when the object is located at the center of curvature. And what we noticed is that the object and the image distance are the same. You can see that down here. DO and DI are the same. Also, the object height and the image height are the same. Of course, the image height is negative because it's an inverted image. So what's been happening is we've gradually been moving this object closer to the mirror. We started with it way out here, and as it got closer, we got to this point where it was right at the center of curvature. And what I asked you to do last time was think about what's going to happen to the image based on what you've seen so far. What's going to happen to the image as the object continues to move closer to the mirror? So if you didn't think about that, take a moment, maybe pause and refer to your notes that you may have taken on previous examples of this, and think about what's going to happen to the image as the object moves closer to the mirror. All right, so I'll do that right now. I'll start moving the object closer to the mirror, and you'll immediately see that the image continues to move farther away, and it continues to get bigger. All right, I'm trying to keep that object right on the 2. I'll stop it right there where the object's at 7. You notice the height of the object hasn't changed, it's still 2. But now look at the image. It's larger than the object. Still inverted, still negative, but it's larger than the object. And of course, the image distance is now larger than the object distance. And as I continue to move that object closer to the mirror, there we are at 6. Now you can see that the image is much farther from the mirror than the object. And the image is now twice as size of the object. Now I want you to notice something very interesting here. There's this neat symmetry to the way all this works out, okay? Notice what happens when DO is 6, DI is 12. That's for a focal length of 4, of course. When DO is 6, DI is 12. If you wanted to right now, you could work out that math. Take your mirror equation, plug in 6 for DO and 12 for DI, and I think you'll see that 4 will be your focal point, your F. All right? Now watch what happens when I move the object out to 12. Look at that. When the object distance is 12, the image distance is 6. Maybe you want to pause and rewind that and see it again. All right? But I'll just go ahead and go back. When the object distance is 6, the image distance is 12. And when the object distance is 12, the image distance is 6. So there's a symmetry there, that they're kind of flip-flop from each other. In addition, here you'll notice that the object is twice the size of the image. When the object distance is twice the image distance, the object is twice the size of the image. And when we move this in, you'll see that the object distance is half the image distance and the object size is half the image size. All right. So there's a lot of neat little mathematical patterns and geometric patterns and symmetries that are going on here that I think it's important to recognize. And the more you mess around with it, the more you'll see that. Now, the last thing I want to ask is this. Watch what happens as I continue to move the object. You see that? The image disappeared. It went off the edge of the screen. Watch what happens as I continue to move the object closer to the focal point. Our next video, which I'm not going to post until tomorrow, our next video will be looking at what happens when the object is at the focal point, and then what happens when the object is in front of the focal point. So those will be the next 2 videos that we take a look at on Tuesday. All right. So feel free to replay any of these. Feel free to plug in the numbers for any of these DOs and DIs and solve the mirror equation. That all would be good practice for Wednesday's quiz, when you're going to have to answer questions about concave mirrors, the images they form, and solving the mirror equation and the magnification equation. Thanks, everyone.